Hello viewers, welcome to another section of my tutorial, and I have a problem in applied electricity. I have this complex circuit here and we have to find the effective resistance. So you say determine the resistance in ohms seen between the terminals A and B of the circuit below. Each resistor has a value 1 ohm. So we are to determine the effective resistance of this entire circuit. So first of all, we are to combine the resistors away from the terminals and gradually to the terminals. So after every point we will redraw and see how the circuit will be. So away from the terminals, you can see that this 1 ohm and this 1 ohm, there is no node in between them, and currents will pass through, or the same current will pass through, so they are in series. So we combine these two and we get 2 ohms. This and this also, there is no node, so the two of them are also in series, so that place will become 2 ohms. We combine the 1 and 1 to get 2 ohms. So redrawing, I'll get my A, then I'll come down and I'll get the combined resistance here. So I'm having this. This might be. So right now I have my 2 ohm here. I've combined this one and this one. I have my 1 ohm here, my 1 ohm here, and 1 ohm here. I also have my 2 ohm here. That is the combined this and this. That gives me this 2 ohm. And I also have my 1 ohm here, and I have my 1 ohm, and as well as my 1 ohm. So from here I can see that this 1 ohm and this 2 ohm, when I traverse through them, I'm not meeting any other elements. There is no node between them two. Sorry, there is a node here and there is a node here. So since there is a node and when I traverse through, I'm not seeing any other elements, they are said to be in parallel. So this one is in parallel with the 2 ohms here. So I have to combine the two. So combining the two, I'm going to get 1 times 2 over 1 plus 2, and that will give me 2 over 3 ohm. So I'll redraw again. I get my A, then have my 2 ohms, then I'll finally get a single resistor here, because this place will be 2 over 3 ohms, this place will be 1 ohm, 1 ohm. I'll finally have another 1 ohm here, 1 ohm here, and my 2 ohms and 1 ohm. So at this point I have eliminated the resistor here, or have combined the two here, so I'm having a reduced diagram here. So at this point I can see that this, or the resistors left, none of them are in series, nor they are in parallel, because there is a node here that's making this place not in series. When I traverse through, I'm going to meet other elements. The same applies to all the elements, so none of them are in series nor in parallel. So we apply the concept of delta star transformation. So this is a delta. I have to convert it to star so that I can make some of them become parallel as well as in series. So we introduce a star connection here, another star like this nicely. Then I'll make here my A, make here my B, and here my C. Now in delta star transformation, if you want to convert from delta to star, we know that this A, to find the value of the resistance A here, A is in between the 1 ohm and the 2 over 3 ohm. So what you do is that you multiply these two resistance and add the 3 resistance into consideration. So my A will be equal to 1 ohm by 2 on 3 ohm all over the sum of all the 3 resistors forming the delta. So 1 ohm plus my 1 ohm plus my 2 on 3 ohm. So this will give me 2 over 3 all over 2 plus 2 over 3, and that is giving me, so 2 plus 2 over 3, and that's giving me 1 over 4 ohm. That is my A. To find my B is in between 1 ohm and the 1 ohm, so it's simply 1 times 1 over 1 plus 1 plus 2 over 3, and that is giving me 1 over 2 plus 2 over 3. And what is that one? 2. So I'm having answer to be 3 over 8 ohms. Finally, my C is in between the 1 ohm and the 2 over 3 ohms. So it's going to be 1 times 2 over 3 over 1 plus 1 plus 2 over 3, which is also equal to the first one, that is 1 over 4 ohms. So I've converted this delta to this star. Let me redraw again and let's see how the diagram will be. So I have my A here, my 1 ohm will come, I have my down here, my 2 ohm here, 1 ohm, 1 ohm. Then after, I'll directly move down here, then down here, and finally down here, and it will also join this one, then it will go to my B nicely. So this the resulting diagram. So my A, which is 1 over 4, my C, which is 1 over 4, and this 3 over 8, like this. From here I can see that there will be some series connection, that is 1 over 4 and 2, 1 and 3 over 8, as well as 1 over 4 and this 1 ohm. There will be series connections here. So let me add 2 plus this, that is going to give me, so 1 over 4 plus 2 here is going to give me what? 1 over 4 will give me 9 over 4. These two give me 9 over 4 ohm. Then 1 plus 1 over 4 here, 1 plus 1 over 4 will give me 5 over 4 ohms. Then 1 plus 3 over 8 will give me 11 on 8. So this place 1 plus 3 over 8 will give me 11 on 8 ohms. Now let me redraw it again. Up here I'm going to have my A terminal going to my 1, then from here I'll get this, I'll get this. So the combined resistance here is 9 over 4 ohms. Then here is going to be 11 over 8 ohms. From here I join it down here. So this place there is no resistor here. I'll close it or eliminate the points. And finally my down I'm going to have up to the B, and here was 5 on 4 ohms. So this is my resulting diagram. I have my 1 ohm here. So from here I can see that my 11 over 8 ohm and my 9 over 4 ohms are in parallel, because I can traverse through without meeting any other elements, but there are nodes here, so that makes them parallel. So 11 on 8 ohm is parallel to the 9 on 4 ohm, and this will give me 11 on 8 times 9 on 4 all over 11 on 8 plus 9 on 4. So this will give me times 9 on 4 over 11 on 8 plus 9 on 4. That will give me 99 on 116. So I'll redraw again. I get my A, my 1 ohm, coming down to the 99 on 116 ohm. Then here's my 1 ohm. This will be in series with the down here, this B. So this is equal to 1 ohm, sorry, 5 on 4 ohms. So from here I'm having this connection. So the 99, this and this and this are finally in all of them are in series. So what are you going to do? We are going to add them. So 1 ohm, this and this are all in series. So we simply add 1 plus 99 on 116 plus 5 on 4. What are we getting? So 1 plus 99 on 116 plus 5 on 4, and that is giving us 3.103 ohms. So this is the effective resistance of this complex circuit, and we have broken it down step by step. This is the end of the video. Thank you. Kindly subscribe and share if you find this helpful. Thank you.